Plus, am I audible? Yes, sir. Okay. I will share the screen. Let me know screen is visible or not. Is it visible? Okay. So in the previous class, we have started discussing on design of circular bunker. Okay, design a circular bunker. So this is what data they have given. 300 kilonewton is the load of the material. M20 grade concrete we need to use, and Fe415. Density of the material is given. Angle of repose is given, that is 25 degrees. Coefficient of friction is given, but coefficient of friction is not required here because we are dealing with bunkers. In the bunkers, do not consider load by friction. In the silos, we consider load by friction. So in the silos, in the design of silos, this data is very important. Coefficient of friction is very important in the design of silos. Okay. So first we have seen the dimensions. Total weight to be retained is 300 kilonewton. Then we have calculated the volume, V1 volume of surcharge. Okay. And after that we have calculated H1. H1, once you got H1, then we have calculated E1. Then after that we have calculated total volume of the bunker. Weight is given, density is given. We find the total volume of the bunker. Okay. Then we have calculated V3, that is volume of hopper bottom. Because see why we have taken minus, because there is opening and it is just like a trapezium. If you see the cross section, it is just like a trapezium. There is opening and the cross section is circular. Okay, so it is a conical shape. That is why we have used this formula, and we have calculated V2, the volume of the middle portion, and after calculating V2, we have calculated H2. Then we have calculated total volume of the coal that is to be retained, and from that we have calculated total weight. Then after that we have started a discussion on design of sidewall. So sidewall has to be designed for the lateral pressure. So this is the formula of lateral pressure, Ph equal to gamma into H cos per pi. So H we have to take of the cylindrical portion. Okay, so this is one second. So this is how your hopper bottom is. You have surcharge like this. Then you have sorry, this is your bunker. This H you need to take. Height of the cylindrical portion you need to take this formula. And we have calculated that is 3.1. Okay. Then see the circular bunker is subjected to hook tension. And we need to find hook tension. This is the formula by which we can find the hook tension. T equal to PH into diameter of bunker divided by 2. And we are getting hook tension, and that is to be factored. Whatever hook tension you got, you need to factor it. So T equal to 1.5 T. And after getting the factored tension, that is hook tension, you need to find the AST. And see, the reinforcement provided for the hook tension will be in the horizontal direction. Okay. So this is the reinforcement that you're getting, but you need to check that reinforcement with the minimum reinforcement, AST minimum. So you can assume the thickness of the bunker. Thickness can be assumed as 140 mm. So from that, you can find the minimum reinforcement that can be provided in the bunker. And whatever reinforcement you have gotten from tension, it is less than minimum reinforcement. So you cannot provide this AST. You have to provide the minimum. reinforcement. And you can assume 8 mm diameter of the bar. You can find the spacing. Spacing is 299.19, and this spacing should be less than 3D or 300 mm. Okay. So provide 8 mm bar at the rate 290 center to center in the horizontal direction. This reinforcement is provided for the hook tension. Okay. And similarly, see, the horizontal reinforcements are provided for the hook tension, and the vertical reinforcement is also provided in the side wall. In the side wall, vertical reinforcement is also provided, and that is the distribution bar. Again, the distribution bar is the minimum reinforcement that is provided in the structural element. So you can provide the same bar because you have taken the minimum reinforcement to calculate the hook tension. Here also you have to take the minimum reinforcement to calculate the vertical bar. Those are the distribution scale. Okay. So we have done the design of side wall. This is the complete design of the side wall. After design of side wall, we need to design the hopper bottom. So we start the class with the hopper bottom. Design of hopper bottom. Design of hopper bottom. Okay. Here you see in the design of hopper bottom. First, you have to decide the thickness of the hopper bottom. So the thickness of the side wall we have taken 140 mm. The same thickness can be taken for the hopper bottom. So take hopper bottom is just like a sloping slab. Sloping slab. Okay. You may also call it as sloping slab. Okay. So thickness adopt sloping slab thickness adopt sloping slab of thickness sloping slab of thickness 140 mm. 40 mm. Okay. And the weight of the coal that is to be retained is weight of the coal. I will write here. Weight of the coal. Weight of coal equal to 304.44 kilonewton. We have calculated this weight in the first step. Now, hopper bottom is like this, and it is having 45 degree with respect to the horizon. Okay, so this is your A. The inclined distance is A, and the vertical distance h3. We calculated h3, and this the vertical distance is 1.5 meter because the horizontal distance is 1.5. The vertical distance will be 1.5 because the angle is 45 degree. Okay, so from this angle and this data, the vertical distance that is 1.5 meter, you can find A. A equals sine theta equal to sine theta, sine 45 equal to opposite. What opposite? Opposite is 1.5 divided by hypotenuse. Hypotenuse is 8. Okay. So A equal to 1.5 divided by sine theta, sine 45. So A, you are getting it as 2.12 meter. The inclined length of the hopper bottom. Okay. A, you have got it. Now you see, we need to find the mean diameter of the sloping bottom. Now see, the diameter is not constant. So this is the hopper bottom that we have. In the bottom, the diameter is different. In the top, the diameter is different. Okay, but we are interested in the mean diameter because the diameter is not constant. So the top diameter is 3.5 meter, and the bottom diameter is bottom opening you can call, or bottom diameter because the opening is in the circular shape. Okay. So we are interested whenever you are dealing with the hopper bottom, we are interested in the mean dimension. Even in case of rectangular bunker, you have calculated the mean dimension. Here also, since the diameter is not constant, the upper diameter is the maximum and the lower diameter is the minimum. You need to calculate the mean diameter. Okay, so mean diameter, and you also have thickness. Okay, so mean diameter plus thickness. Mean diameter plus thickness. 140 mm divided by 2 plus 140 mm divided by 2. Okay, so mean diameter of sloping bottom, mean diameter of sloping bottom or hopper bottom, whatever you can call, sloping bottom equal to 3.5 plus zero point 0.5 divided by 2. This is from here to here, it is a mean diameter plus thickness because you are interested in the effective span. So since you are interested in the effective span should be from the center to center distance of the thickness. Okay, plus 0.140. So this is coming as
हेलो सर.
2.14 meter. Yes,
सर 1 मिनट थोड़ा ऊपर करो ना.
ऊपर ठीक है. बस.
जी
इतना
सर,
बस.
ये साइन साइन 45 कैसा लिए सर आपने, मतलब अपोजिट
साइन 45 अभी देखो ये अपोजिट है ना आपका.
अपॉन होता है ना साइन तो.
अपोजिट ये है ना आपका.
जी सर, अपोजिट 1.5 है.
हाँ, और हाइपोटेन्यूज क्या है.
ए ए. ओके सर, ओके,
बरोबर है
गॉट
ना.
इट.
ठीक है. ओके. Now, so see, the hopper bottom is subjected to total weight of the material. See, in order to design hopper bottom, we need total weight that is coming on the hopper bottom. So weight of the coal you need to consider plus self weight of the hopper bottom. So weight of the coal we know that is 304.44 kilonewton. We know is the total weight of the coal, and that total weight is coming on the hopper bottom. And also we need to find the self weight of the hopper bottom. So we should get total weight. In order to design the hopper bottom, we should get the total weight. Okay. So here you will find the weight of the hopper bottom. Okay, this is self weight of the hopper bottom. Self weight of the hopper bottom. Self weight or weight of the hopper bottom, whatever you want to call. Self weight of hopper bottom slab. Hopper bottom slab. Okay, so here you need to consider the circumference distance because it is in circular. So which diameter you will take? You will take the mean diameter. So what mean diameter you have gotten? You have gotten 2.14. Okay, pi into d, circumferential distance into thickness of the hopper bottom. That is 140 mm into inclined length, that is A, into density of the concrete. So this is how you can find the self weight of the hopper bottom. Okay. So pi into 2.14, we will take the mean diameter. Thickness is 0.14, 140 mm. A, we have calculated the inclined length of the hopper bottom. We have calculated it is 2.12 into 25. Okay. The self weight is coming as 49.885 kilonewton. But we need to consider the total load. This is the weight. The total load, the load of the coal that is to be retained, and self weight of the hopper bottom. So total vertical load, total vertical load equal to 304.44 is the load of the coal that is to be retained plus self weight of the hopper bottom. Just now we have calculated. So this is coming as 354.325 kilonewton. Okay. So this is the total load that is coming. So from this total load, we need to find a tension in the hopper bottom. So this is your total load. Okay. This is your total load that is going in this direction. And from this, we need to find the tension. So this is the tension in the hopper bottom that is running. So if you take the vertical component of this, it will be T sine theta. Okay, so we need to find tension per meter. See, we are not just finding tension, we are finding tension per meter. Per meter means the circumferential distance. Okay, so it is equal to total load, that is 354.35 divided by sine theta, sine 45, because T sine theta equal to W. So T equal to W divided by sine theta. Okay. But we are finding tension per meter. Per meter means the circumferential distance that we need to divide here. Pi into 2.14. So tension per meter equal to uh, 74.54, 74.53 kilonewton per meter. Now, from this tension that we have gotten, we need to find the factored load, TU 1.5 into 74.53. This is coming as 111.80 kilonewton per meter, because we have taken per meter, tension per meter. Okay. So from this, we can find the AST. AST, we know the formula. AST for the tension, AST TU divided by 0.87 FY. 0.87 FY. This is coming as 111.80 into 10 to the power 3 divided by 0.87 into 415. This is equal to 309.65 mm square. Okay, which is greater than AST minimum. So what is AST minimum here? AST minimum here is 168. So whatever the reinforcement here that we have gotten, it should be greater than the minimum reinforcement. Then we can take that reinforcement. Okay. So we can try for 8 mm bar. Try 8 mm bar. 8 mm bar. Okay. Spacing, you know how to find the spacing. You know the formula of the spacing. So I will write the formula and I will directly write the spacing, whatever spacing they get. Area of one bar into uh, width divided by AST. Okay. So area of one bar, 8 mm bar we are considering here, into width, that is 1000 mm, divided by AST. Whatever AST you have gotten, you have to get 162.33 mm. Okay. So this spacing should be less than maximum spacing. Maximum spacing is equal to 3D or 300 mm. So whatever spacing that we have gotten, it is less than the maximum spacing. Okay. So we can write down the detailing. Provide 8 mm bar at the rate 160 m in the sloping direction. In the sloping direction. Sloping direction. Okay. So you see the hopper bottom is subjected to two forces. One is direct tension and other is hook tension. So the reinforcement that we have calculated, it is for the direct tension. And this reinforcement has to be provided in the sloping direction. So this is the slope that you have, and reinforcement will be provided in this direction, in the sloping direction. Okay, and we will also provide horizontal reinforcement. That is because of the hook tension. We have to calculate that. We will see, but this reinforcement has to be provided in the sloping direction, which is parallel to the upper bottom. Okay. So one more reinforcement that we need to provide. write down B. Reinforcement for hook tension. Reinforcement for hook tension. Reinforcement for hook tension. Okay. So here we need to find the average depth. This is your bunker like this. Bunker is like this. Okay. So this is the hopper bottom that we have. But we are interested in the average depth. Average depth. Half the height of the surcharge. What is surcharge? Surcharge is 0.82 divided by 2 plus height of the cylindrical portion, that is 3.1, plus height of the half of the height of the hopper bottom. Height of the hopper bottom is 1.5, but we are considering average. So from say average from this point to this point. So this distance we need to consider when we are finding the normal pressure in the hopper bottom. So hook tension is because of normal pressure. So I will tell you the formula. So this is 4.26 meter. So theta is 45 degree and phi is angle of repose, that is 25 degree. And you know the formula of Pn. Already I have given you the formula of Pn. Uh, Gamma into h, h is the average depth, into cos square theta plus cos square phi into sine square theta. So I have already given you this formula. Okay. You will get the, after substituting value, you will get the normal pressure. And you also have to add the weight of the material. Sorry, weight of the hopper bottom. I will tell you that. First, you will find this hopper bottom. So it's normal pressure. 8 into 4.26. Just now we have calculated 4.26 into cos square theta. Theta is 45 degree plus square phi. Cos square phi. Phi is 25 degree into sine square theta. Theta is 45 degree. So this is coming as Pn is coming as Pn equal 31.04 kilonewton per meter square. Okay. But we also have to find, see, what is normal pressure? Again, I will tell you. This is normal pressure, Pn. But weight is also going in this direction. You have to consider the resolution of the weight normal to the plane. So weight is going vertically downward, but it has some effect normal to the plane. Okay. So what is that? If you take this as theta, so weight equal to W equal to cos theta, self weight of the hopper bottom, into cos 45. Okay. So I will write normal pressure due to self weight of the sloping slab. Normal pressure due to self weight of the sloping slab. Self weight of the sloping slab and self weight of the hopper bottom. Okay. Equal to W 49.885. Just now we have seen into cos theta, cos 45. Cos 45. This is coming as 35.27 kilonewton. But we are interested in the per meter distance. This is kilonewton, total load, but we are not interested in the total load. We are interested in the kilonewton per meter. Okay. So again, normal pressure due to self weight divided by per meter. So circumferential distance you need to divide because we are dealing with the circular bunker. 35.27 divided by circumferential distance, that is pi into d. D, what is d? D is the mean diameter, 2.14. So this is coming as 5.25 kilonewton per meter. Okay. So total normal pressure per meter. Okay. Total normal pressure total normal pressure per meter equal to 31.04, that is your Pn, plus normal pressure due to weight, that is 5.25. Okay, so this is coming as 36.29 kilonewton per meter. Now we can find the hook tension. Now we can find the hook tension. Okay, you know the formula tension. Hook tension, hook tension per meter run equal to Pn, that is total normal pressure, into D. See, Pn is not just Pn, it is total normal pressure. That this is your Pn, okay? Total normal pressure into diameter. Which diameter you have to take? You have to take the mean diameter because you are dealing with the hopper bottom, divided by 2. Okay. So Pn is 36.29 into mean diameter is 2.14 divided by 2. So the hook tension T equal to 38.83 kilonewton. This is your hook tension that we need to factor. Okay, so we need to multiply 1.5 to it. Tu equal to 1.5 into 38.80, which is equal to 58.245 kilonewton. Okay, so you can find AST. You know how the formula of AST for TU. TU divided by 0.87 Fy. TU divided by 0.87 Fy. Okay, so this is coming as 161.32, which is less than AST minimum. What is the value of AST minimum? Already we calculated. The value of AST minimum is 168 mm square. Whatever AST we are getting for the hook tension, it is less than AST minimum. So we cannot consider whatever AST we have calculated. We need to consider the AST minimum. That is 168 mm. 168 mm square. So you need to consider 168 mm AST equal to 168 mm square. So you can provide 8 mm bar. Provide 8 mm bar at the rate 290 mm center to center. Okay, I will show you the detailing. Detailing will be like this. So this is how the detailing of the circular bunker will be. You have edge beam, then you have side wall. Okay, in the side wall you have two reinforcement. One is reinforcement for the hook tensions, that will be in the horizontal direction. Another is the distribution bar. Distribution bar will be vertical. Vertical, and we have seen the detailing of the distribution bar, that is 8 5 at the rate 290 mm center to center. And the horizontal reinforcement is for the hook tension, the side wall, that is for the hook tension in the side wall. So this is also 8 mm at the rate 290 mm center to center. Okay, so the horizontal reinforcement is also 8 pi at the rate 290 mm center to center. The vertical reinforcement is also 8 pi at the rate 290 mm center to center. Now we'll see the distribution part. Okay, so hopper bottom will be like this. This will be your hopper bottom. Here you have edge beam. You can continue this part. You can take up and here you have a beam. You can join this to the beam. Then from the beam you have another reinforcement in the sloping in the direction of the sloping slab. So this reinforcement is for the direct tension, and you're getting it as 8 pi at the rate 160 mm center to center. And here also you have the horizontal reinforcement, and that is for the hook tension in the hopper bottom. Okay, so this is the horizontal reinforcement is 8 pi at the rate 290 mm center to center. So this is your detailing. I will just, this is your detailing, the complete detailing of the circular bunker. Okay, this is how you complete the design of circular bunker. You have any question you can ask. We have completed the design of circular bunker. Okay, in the next class, we will start design of silos. Tomorrow, I will take in the morning because in the afternoon I'm busy. I have my duty, exam duty. Tomorrow, I will start design of silos, and I will only take one problem of the design of silos. I think in the 2 hours, it will be completed. Okay, you have any question you
हेलो।
can ask? Yes.
हाँ सर, वो हसीब बोल रहा हूँ। पूछ रहा था सर, आपका यूटी 2 का कुछ असाइनमेंट वगैरह है हमको कंप्लीट करने है सर?
असाइनमेंट देता हूँ मैं। अगर आप लोग के पास यूनिवर्सिटी क्वेश्चन पेपर है क्या आप लोग के पास?
अभी तो नहीं है वो लाइब्रेरी से, लेकिन ले सकते हैं। पास्ट का 1 या 2 मिल जाएंगे।
हाँ, तो यूनिवर्सिटी क्वेश्चन पेपर 3 पेपर आपको रेफर करना है। तीनों पेपर के
हाँ।
जो थियरी क्वेश्चंस हैं
हाँ।
वो आपका तीन पेपर
तो
आपको
सर
रेफर करना है
उसमें
यूनिवर्सिटी के।
वही यूटी 2 हो जाएगा ना सर? फिर वो जो असाइनमेंट रहेगा।
असाइनमेंट आपका यूटी 2 हो जाएगा।
हाँ ठीक
क्योंकि
है।
या तो हमें 2 यूटी लेना है या एक यूटी लेना है, एक असाइनमेंट लेना है। तो हम क्या कर रहे हैं, एक यूटी ले रहे हैं
ठीक है सर।
और दूसरा एक असाइनमेंट। तो असाइनमेंट मैं मैसेज भी डाल देता हूँ ग्रुप में। आपको 3 साल के ना यूनिवर्सिटी क्वेश्चन पेपर रेफर करने हैं, और उसमें से जो थियरी क्वेश्चन है, ठीक है, मैं एक काम करता हूँ, मैं बहुत ही क्लियर कर देता हूँ, है ना। ग्रुप में क्लियर कर देता हूँ, मैं आपको क्वेश्चन पेपर भी शेयर करता हूँ, और उसमें से कौन कौन से क्वेश्चन आपको करने हैं असाइनमेंट में, वो भी मैं आपसे शेयर करता हूँ। ठीक है, एनी
ओके सर।
क्वेश्चन?
सर UT1 में क्या होगा?
ओके सर।
यूटी 1 में आप लोग ही बताओ मुझे क्या चाहिए आपको। 2 टॉपिक मैं दे सकता हूँ यूटी 1। अभी देखो, अभी हमारा आज कल हम अपना 3 मॉड्यूल हो जाएगा, ठीक है। हेलो, सुन रहा है क्या कोई?
यस सर।
हाँ सर।
हाँ, अभी अपना
सर
तीसरा
फ्लैट
मॉड्यूल
स्लैब
चलता है।
डिजाइन रहेगा ना यूटीसी में?
वो आप लोग के ऊपर, आप लोग अगर फ्लैट स्लैब बोल रहे हो तो मैं फ्लैट स्लैब दे देता हूँ, और 2 टॉपिक रहेगा, एक तो फ्लैट स्लैब रहेगा, दूसरा बंकर साइलेंस दे देता हूँ।
आज वाले ही दे दो।
ये वाला दे दो, ऐसा नहीं, मैं ऐसा नहीं दूंगा, टॉपिक में से दूंगा।
सर पर उसमें ऐसे रहेगा क्या, मतलब एनी वन क्वेश्चन फ्लैट स्लैब और
वो मैं आपको
बंकर
नहीं
स्लैब?
बताऊंगा, वो मैं आपको नहीं बताऊंगा। 1 रहेगा, एनी 2 रहेगा। आपको 2 टॉपिक दिया जाएगा, दोनों टॉपिक आपको पढ़ के आना है।
तो बंकर और फाइव भी ले लो सर।
ओके ठीक है सर।
वो आप लोग डिसाइड करके मुझे बोलो। आप लोग आपस में पहले डिसाइड करो, दूसरी भी राय है, फील्ड लाइन थ्योरी में मैंने सिखाया है। हाँ, इसके बाद है ना अपना
सर
ज्यादा
जो भी
टॉपिक नहीं
रहेगा आप
बचा
ग्रुप
है।
में,
तो मैं आप मेरे हिसाब से
आप
दे
ग्रुप
दूं
में
कि आप
डाल
लोग
देंगे
डिसाइड
सर जो
करोगे?
भी रहेगा।
मेरे हिसाब से दे दूं?
आप अपने हिसाब
हाँ।
से ही,
नहीं, अगर आप
हाँ
लोग
ग्रुप में
डिस्कस
रहेगा
करके बताएंगे तो
अपने
आप
हिसाब
लोग
से।
अच्छा रहेगा ना वो। मैं मेरे हिसाब से दूंगा तो फिर आप किसी को तकलीफ भी हो सकती है। मैं यील्ड लाइन थ्योरी भी दे सकता हूँ। तो आप लोग का
ओके
अनऑफिशियल ग्रुप
फ्लैट
ठीक
है, डिस्कस करें,
है
स्लैब
सर।
डिजाइन।
डिस्कस करके मुझे बताएं। और दूसरे टॉपिक भी कवर हो जाएंगे ना तब तक, जैसे कंबाइंड फुटिंग में लूंगा, और स्ट्रिप फुटिंग है, फिर कॉर्बल, डिजाइन ऑफ कॉर्बल है, और पोर्टल फ्रेम का डिजाइन है, ये सारे डिजाइन बचे हमारे। ठीक है, तो ये
हाँ
सारे
सर,
डिजाइन में
फुटिंग
जब लूंगा तो अपना सिलेबस है ना लगभग कवर हो जाएगा।
फुटिंग
ये देखो कौन कौन से टॉपिक
हाँ
में बचे हैं
फुटिंग भी
बताओ।
ओके
डालिए
सर।
एक।
ठीक है।
डिजाइन ऑफ कंबाइंड फुटिंग बचा है, डिजाइन ऑफ स्ट्रिप फुटिंग बचा है, फिर डिजाइन ऑफ फॉर अच्छा है, और डिजाइन ऑफ पोर्टल फ्रेम जो 20 मार्क्स का आता है एग्जाम में, मेन एग्जाम में ना 20 मार्क्स का आता है। डिजाइन ऑफ पोर्टल फ्रेम में आपको पूरा डिजाइन करना है, कॉलम, स्लैब, बीम, फुटिंग, सारे एक पोर्टल फ्रेम में क्या क्या चीजें रहती है। स्लैब रहता है, स्लैब से लोड कैसा आता है बीम में, बीम से लोड कॉलम में कैसा आता है, फिर कॉलम से फुटिंग में कैसा आता है, तो ये सारी चीजें आपको डिजाइन करना है। ठीक है, ये टॉपिक अगर हम कवर करते हैं तो लगभग हमारे सिलेबस जो है कवर हो जाता है। बाकी थियरी क्वेश्चंस है, थियरी में आप लोग यूनिवर्सिटी क्वेश्चन पेपर रेफर करके जो रिपीटेड ही आते हैं, थियरी क्वेश्चन आप लोग वो रेफर करो, उसमें से, है ना। वो तो मैं आपको असाइनमेंट ही दे दूंगा, असाइनमेंट आपको, आप लोग का लिखना भी हो जाएगा और पढ़ना भी हो जाएगा। थियरी क्वेश्चन कम आता है, पर आता है, रिपीटेड ही आता है। आप लोग वो यूनिवर्सिटी क्वेश्चन पेपर देख लो, और इसमें से थियरी क्वेश्चन जो जो है वो कर लो, उसके उसमें से आसपास उसी में से आएगा। ठीक है, और कोई सवाल है?
ओके सर।
हाँ, ये टॉपिक समझ में आ गया सबको? समझ में नहीं आया तो यू कैन सी द रिकॉर्डिंग। जैसे ही मैं मेरा क्लास हो जाता है मैं रिकॉर्डिंग शेयर कर दूँ। ठीक है, ठीक है, मैं अटेंडेंस ले लेता हूँ, कल मैं सुबह ले लूंगा, मैं आपको टाइम बताता हूँ। कल हम लोग डिजाइन ऑफ साइलोज शुरू करेंगे। डिजाइन ऑफ साइलोज इज ऑल्सो वेरी इंपॉर्टेंट टॉपिक। ओके, जस्ट शेयर मी योर अटेंडेंस। You call your name. No, no, not in the chat box.
हसी
Okay,
बोला
वालेकर सर।
दानिश।
this has been recorded, and your attendance will also be recorded in the session. You call your name. I will repeat the name. Then you
मूसा
can
बुरहान।
stop. Musa Burhan,
अब्दुल्ला।
Abdullah,
हसी
मुस्तफा।
कौन?
मुस्तफा।
मुस्तफा। नेक्स्ट।
हसी वालेकर
उसामा।
सर।
ठीक है, बोलो, कौन नेक्स्ट?
उसामा।
ओसामा। नेक्स्ट।
अरमश हसी वालेकर सर।
अरमाश। अरमाश। नेक्स्ट कौन है नेक्स्ट?
दानिश।
हसी वालेकर सर।
हासिब आलेकर, हाँ। उसके बाद
तारिक
दानिश।
दानिश। ओके, उसके बाद नितिन सालुंके। ठीक है, उसके बाद
शारिक शारिक नदीम।
शारिक नदीम। ठीक है, और
सर सुल्तान हो गया। सुल्तान।
सुल्तान। सुल्तान, ठीक है, और कोई बचा है?
कुणाल जोशी।
कुणाल जोशी, ठीक है, कुणाल जोशी। नेक्स्ट। सब है ना अटेंडेंस? सबका अटेंडेंस हो गया ना? ठीक है,
यस
आई
सर।
विल जस्ट।
यस सर। प्रवीण सावंत।
प्रवीण सालुंके, ओके। प्रवीण से किधर थे तुम? हाँ, तुम अब भी बोल रहे हो। अटेंटिव नहीं थे क्या क्लास में?
नहीं सर, ऑफिस में हूँ।